Hello and welcome to Module 3 test review. So Module 3 was all about translations, dilations, reflections, rotations. Yeah, I think I got them all. Those guys. So basically geometric transformations. So let's get right to it. Triangle ABC is reflected across the y-axis, then rotated 90 degrees counterclockwise about the origin. Would the image A prime, B prime, C prime be bigger, smaller, or the same size as the original? Okay, so we have some triangle. It just says ABC. It doesn't tell us much about it. And this guy is reflected across the y-axis. So it comes over here. CBA, so it flipped over the y-axis, and then it gets rotated. Would the new shape be bigger, smaller, or the same size? Well, we're not doing anything to change the size of it. It's just being like turned and flipped over. So the size would be the same. It's the same size. And the reason why you could say that is, and I'm not going to write out my whole explanation, you can do your own, but the reason why it's the same size is no dilation happened. Dilation is the only type of transformation that we have that changes the size of an object. That would change its perimeter, change its area, change everything about it, is the dilation. Since the no dilation happened, the perimeter, area, size, everything is exactly the same as it was before. And that's what I'd say. I'd say it's the same size because no dilation occurred. Number 3. What happened to number 2? Well, there is no number 2. Yay us. One last question. Number 3. Give a sequence of transformations that maps ABC to A prime, B prime, C prime. All right, so you got to find some sequence of transformations that turns this shape into that shape. There are a variety of ways of doing this. The first thing that I see is I like the idea of reflecting this across the x-axis. So if this guy reflects down here, it looks like that with A, B, C. And you see that's very close to that same shape right there. And then all we'd have to do is translate it over. So I'm going to say we're going to reflect across x-axis, then translate. Translate is the move, by the way. So reflect flips it. Translate is to slide it over. A rotation is a turn. And a dilation makes something bigger and smaller. So we're translating it to the left. How many places? Well, take one point. I'm taking point C here. And you're going to move it until you get to point C over here. 1, 2, 3, 4, 5, 6 places. This would work. You could also say you could reverse those two directions. If you said move left 6, 1, 2, 3, 4, 5, 6, it would look like this. Move left 6, then reflect across the x-axis. You see you get the same thing. Number 4, James drew 3 triangles below. Aren't they beautiful? Which 2 triangles are similar and which 2 triangles are congruent? Explain why. All right, so we got to know the difference. Similar triangles are 2 triangles that the old school definition is they're the same shape but a different size. That was like the old school definition of similar figures. A better way to say that is they're 2 figures that are proportional. That's what similar means. Congruent, on the other hand, basically means equal. They are exactly the same everything. Same shape, same size, same perimeter, same area, same everything. Okay? So which 2 shapes are similar? Well, I'm looking at B and C here because they give me a lot of information here. And these 2, like 10 and 10, 8 and 8, 12 and 12, those 2 are identical. But you're going, Mr. Henry, but like the 8's on this side and the 10's on this side. Well, there's probably a reflection here. It just kind of flipped over from B to C. So they are congruent. Oh, not that button. They are congruent. So I'm going to say B and C are congruent because their sizes are the same. The shape is the same. Now, which two are similar? Well, I mean, I'm looking at letter A because I haven't used him yet, and I see it gives me angles 43, 62, 75. 43, 62. I bet you this angle right here is a 75 as well. These two guys are congruent. One of the properties we learned about, oh, I'm sorry, not congruent, similar. Sorry, similar. These two guys are similar, and one of the properties we learned about said that all similar figures have the exact same angle measures. That kind of makes them the same shape, which these are the same shape, and they're not the same size. Triangle A, hopefully you could agree, is bigger than triangle B. So A and B are similar, B and C are congruent. And just for those out there, you could also say that A and C are similar, but there's not a lot of, there's not a lot of information on the page to connect them, but they are similar because if these two are exactly the same, and A is similar to the first one, then he would be similar to the second one as well. Number 5 says, a blue police box is sitting on a street next to an alien Dalek. So there's your blue police box. There. Now he's blue. He's sitting next to the alien Dalek. Alien. The doctor, good guy, knows his police box is 7 feet tall. By the way, I haven't opened this file before today. For the last time I did this with one of the classes. This is what I would actually do if I was taking this test for real. Like, I'm reading the problem for the first time with you right now. So he's 7 feet tall. I label my picture 7 feet tall, and is currently casting a shadow 3 feet long. So I draw a shadow, and I label it 3 feet long. The alien is casting a shadow 2 feet long. I draw a shadow. I label it 2 feet. Help the doctor find the height of the Dalek. Okay, so we want to know, what is this? What is this height right here? Well, this is two similar triangles, or these are two similar triangles. Yes, they're both right triangles, but the right triangle thing doesn't really help me find x. What does help me find x is the fact that they're similar, because this is proportional. Similar figures are proportional. I can set up a proportion to find a missing side of one of my figures. So if I set up the proportion 7 over 3 equals x over 2, and if I cross multiply and solve these similar figures, I can find my missing side. So 7 times 2 is 14, 3 times x is 3x, cross multiply. And when we solve here, divide both sides by 3, x equals 2.6 repeating. No, 4.6 repeating. I was trying to do this in my head and I screwed it up. 4.6 repeating. So the Dalek is 4.6 repeating feet tall. Triangle JKL is similar to triangle JRS. What is the perimeter of triangle JKL? So I'm trying to find the perimeter of this triangle right here. And I was hoping this was going to be the first of these module tests that didn't have a typo on it, but I remember, because I just did this test with my one class not long ago, that there is a typo here. So let me think about this for a second. The fix for the typo was to change this guy to 18, but if you guys did the problem ahead of me, which you probably did, you wouldn't have known that. So basically what you would do is, the way I would recommend you do this problem is you would draw your two triangles separately from each other. This would be the big triangle KLJ. This would be the small triangle SRJ. Label what you know. That's 15. That's 10. That's 12. This side is not 14.4. It's what you get if you combine these two sides together. If you add 14.4 plus 12, you get 26.4. If you add these two together to get the length from L to J, you would get 37.5. And then to find the perimeter of JKL, basically all we need to do is we need to find this side here. And we can add up these three sides, and we have ourselves a perimeter. Now, the typo, the problem, was that these sides are not actually in proportion. I know, shame, shame, Mr. Henry. They should have been. And you're right, they should have been. So depending on how you set up your proportion, though, you could still potentially get a right answer. I mean, if you set up, say, these two and these two to find this x, what would we get? Well, we'd get x over 26.4 equals 10 over 12. You'd cross multiply, and this side you'd get 12x. This side you'd get 264. Divide both sides by 12. X equals 264 divided by 12 equals 22. So then if x is 22, you'd add all three of these sides together, and you would get a perimeter. 22 plus, what was it? 26.4 plus 37.5. So if you got an answer of 85.9, good for you. You did it one of the correct ways. Even though there's a typo, I'll accept that as an answer. By the way, if you stopped at 22 and thought that was your answer, you forgot your job was to find the perimeter. You found what x is. You found the missing side of this triangle. That was it. Now, if you didn't use those two sides, let me see how much I can click on and delete here. Click, delete, nice. Click, delete, and erase this junk. If instead you used these two sides to set up your proportion, you're going to get a slightly different answer. X over 37.5 equals 10 over 15. And you cross multiply, you get 15x equals 375 divided by 15 on both sides. X equals, I don't know, 375 divided by 15 equals 25. Okay, so that's what I was saying. Like, if there's a typo, depending on how you set it up. If you got 25 for x using this proportion, good for you. You did it right. If you got 22 for x because you used the other proportion, good for you. You did it right. You probably would have never even known there was two answers to this problem unless you did it both ways. And then if you used 25 and you did the perimeter and you added them all up, 25 plus 37.5 plus 26.4, whoa, too big, 26.4 equals 88.9. So if you got one of those two answers, good for you. If you got 22 or 25 for your answer, you found the missing side using a proportion, you just didn't find perimeter. If you didn't get any of that, ooh, my recommendation for most people who struggle with this problem is to do this. Separate it into the two separate triangles first. Label everything you can. Usually once you do that, you start to realize it's not so bad, and you can set up a proportion and go through that stuff. Number 7. Are the images below similar or congruent? Well, congruent means exactly the same. Same shape, same size, same everything. They're not. This guy's clearly smaller than that guy, so they're not congruent, and if those are my only two options, then I'm going to say these guys are similar. And I'm going to say they're similar because they're probably proportional to each other. This smaller triangle, you could say it's a scale factor of like 1/2, a dilation of scale factor of 1/2. It's smaller, and that makes it similar. Similar figures are proportional. I-O-N-A-L. It's the same shape, different size. Their sizes are different, even though the shapes are the same. So we're going to say they are similar. And give some reason of why. You don't need to sit here and listen to me watch me write a paragraph. Last two. Number 8. Determine whether the following statements are true or false. Ooh, nice. Figure 1, which is this guy up here, maps to figure 2, After reflection across the x-axis, okay, let me do that. So this is going to go down 3, and it goes like this, here, here, here. Okay, so there's my reflection across the x-axis. Oh man, I read it wrong. Oh, this one's okay. So I'll do this one since I already did reflect across the x-axis. Across the x-axis, check. Then across the y-axis. So if I flip this across the y-axis, then would this line up with this shape over here? I'm counting boxes. It's 1, 2, 3 away. 1, 2, 3 away. Yes, it would. Why, yes, it would. This is true. If you reflect across the x-axis and then the y-axis, then figure 1 would look like figure 2. Okay. Now, let's do it the first one for reals this time because I messed up the first time. If you reflect across the y-axis first and then the x-axis, so across the y-axis would be here, 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 here. Ain't he beautiful? All right, so I reflect across the y-axis, and then across the x-axis, you'd go down. Yes, and this point goes down 3, down 3. This point, down 5, down 5. Yes, down 5, down 5. You see how it's lining up? Down, I don't know, 7, down 7. So, yes, if you reflect across the y-axis and then the x-axis, that also makes these two guys equal to each other. They land on top of each other. Figure 1 to figure 2 by a translation up by 10 units. If I take this guy and I go up 10 units, is it going to look like that? Well, no, it's going to be like way up there somewhere. No, that does not work. Even if you're looking at this one to that one, straight up 10 units just puts it up here somewhere. That's not going to work either. Figure 1 maps to figure 2, following a counterclockwise rotation around the origin. So if I would spin this shape around the origin, does it eventually land right here? The answer is yes, it does. It's the same distance away from the origin on both sides. This is kind of like, think of this as like the radius of the circle of the rotation. As this spins around, this point lands right there. And this point out here, as he spins around the origin, he lands right there. This is a rotation of 180 degrees. Notice it doesn't say how far. It just says some rotation. It's a 180-degree rotation about the origin. Last problem. Consider each transformation described below on the given pre-image. Would the pre-image be congruent to, similar to, or neither congruent nor similar to the image? Write each transformation in the correct box. All right, so first one. If I take this shape and I shorten each side by 3, so this would, I'm just going to kind of sketch it. 7, 15, 9. Would these two shapes be congruent, similar, or neither? Well, they're not congruent. They're not exactly the same shape and size. Similar? I don't know. I'd have to set up a proportion. So I'm just going to pick two sides and set it up. 7 over 15, 10 over 18, cross multiply. 15 times 10 is 150. 18 times 7 is not 150. That's 126. So they're not similar because they're not in proportion. They're not the same, so that means they're neither. So if you shorten each side by 3, that is not similar or congruent. Second one, reflect across the y-axis. So if you took this guy and you flipped it over here, would they be the same shape and size? Would one be bigger or smaller than the other, or neither? The answer is they're congruent. That would just the shape and size did not change. You're just kind of flipping it over. Like if you take the calculator on your desk and you flip it over, it didn't become bigger or smaller. It's exactly the same shape and size. It's just flipped over. So reflect across y-axis is congruent. Third one, dilate with a scale factor of 1/2. Well, that's pretty much the definition of what it takes to make something similar. Two shapes are similar if a dilation happened, if the shapes are in proportion. So I know that that is similar. Dilate with scale factor of 1/2. By the way, we use the r variable for scale factor for some reason, but we do. Next one, translate down 6 and then rotate 180 degrees. So if I took this guy and I went down 6 and then turned it 180 degrees, would it be the same size or different size? Well, I'm not doing a dilation, so it'd have to be the same size. So, and since it's the same size, those would be congruent shapes. So this is the translate down 6 and then rotate 180 degrees. So that is congruent because it's the same shape, it's the same size, it's just in a different location. Last, he says multiply the length of each side by 2. Okay, this might be one of those weird ones like this. So if I take each side and times it by 2, so you got 20, you got 36, you got 24. I got to check, is this similar? So I'm going to take, use those two sides, set up a nice pretty proportion. 10 over 18 equals 20 over 36. If I cross multiply here, 10 times 36 is 360. If I cross multiply here, 18 times 20 is 360. So those two are in proportion. That means they're similar. They're not the same exact size, so they're not congruent, but they are in proportion, which makes them similar. And that is it. So this has been the Module 3 practice test. Thank you for sticking with us. Bye-bye.